and throughout the rest of the course, we're going to be doing a lot of transformations and we're going to be applying these transformations to all types of different functions. Okay? We're not going to be just doing transformations, but they're going to slide into their respective places throughout the rest of the course. So you're going to have to know how to do these transformations. Now, it's a lot easier doing it on a calculator, but um, we have to know how to do them manually because there are transformations on the no calculator part of the SATs, which you guys are have circled on your calendar and so excited to be looking forward to that date, right? Uh, yeah, it's next semester. I don't see a whole lot of happy faces about that. But anyway, all functions that we look at, whether it's the absolute value function, the exponential function, radical functions, they have what's called a parent function, or as our worksheet says, they call it the mother graph. I call it the parent function. I always did. So you'll always hear me reference the parent function. Okay. And today we're going to look at the absolute value function because it's one of the easiest to look at and see the transformations. Now, what do I mean by transformations? It's just the way we're going to be shifting the graph. Okay. Whether we shift it up, down, left, right, we even shift it stretching and making it thinner and wider. Okay. So we're just shifting the graph. That's what transformations are. And like I said, every function has what's called a parent function. And basically, what it is, it's just a stripped down version of what the function is. The absolute value function is y equals the absolute value of x. Now, if you put this in your calculators, your handy dandy calculators, we'll get what the parent function or the function of absolute value looks like. So let's go to our y equals, and it tells you up here, you can find the absolute value command under the math menu, hit the num button, or go to the num, and then the number one is the ABS, which is absolute value. In other words, we're going to hit the math button, and we're going to highlight the num for numbers, obviously. Huh? You need a graphing calculator. Yeah. Yeah, just pick an empty one for now. Okay, so you go to num, and then you're going to hit absolute value, which is highlighted already. So all you have to do is hit the enter button, and it puts in the absolute value for you. Okay. So
Interruption. The shop bus just returned. It was a little late, so please allow students in the class. Once again, the shop bus was late today. Please allow students in the class. Thank you.
so we're doing the absolute value of x. So we're going to hit the x button here, puts in an x. Then I have to close off the parentheses, and then I'm just going to hit graph. And there's my parent function. Okay, hit your y equals.
Oh, you didn't mention that.
Yeah, because that's this part of the equation, the y equals. Okay. And then here, I'll clear it out and do it. And then go to your math button.
Okay, yep, I got it.
Got it. Okay. And we're going to put an X in there, close it out,
Yep, I
and
got
grab.
it.
Now, you're going to have to know how to do these manually. And to do that, you're going to have to use your T charts. Remember? T charts from, oh, we just did that yesterday. So I have an X and a Y. I choose the X. The easiest X to choose is 0, right? If I put in 0 for X, the absolute value of 0 is 0. So there's my Y. If I put in 1, the absolute value of 1 is 1. So Y equals 1. If I put in -1, I put in -1 for x, the absolute value of -1 is +1. So there's my 3 points. If you use your calculator though, go to hit the second button and the graph button for your table and kind of ignore this column for now. Um, if you notice, there's my 0, 0, my -1, 1, and my 1, 1. So you could always get the points off of there. But like I said, on your SATs, they have transformations on there. You're going to have to figure out some points to draw the graph. Okay, so I'm going to plot 0, 0, 1, 1, and -1, 1. And draw my V. If you're using your calculator, hit the second key and the graph button and it brings up your table, your XYT chart.
On my calculator, hit the second.
Yep, hit the second button and the graph button. Okay, and it brings up your table. And the vertex, I usually on your calculator, now this doesn't happen all the time, but it does for the parent function because it's it's nice. So most of the times you can figure out this point right here. That's called the vertex. You can usually figure out the vertex on your calculator because look at the y's. They start to repeat. There's 1, 1. There's 2, there's 2. Okay? So I know that 0, 0 is going to be the vertex. Most of the times your calculator is going to do this. Now, not all the time. If you get into more complicated absolute value functions, it's sometimes they don't show you the vertex, the table. It doesn't show you the vertex. Another important thing about this this parent function, there's a line of symmetry for all absolute value functions. Okay? This is a line of symmetry, which means this half is exactly like that half. It's kind of like a mirror, right? That's the line of symmetry for the absolute value for this absolute value function. It happens to be the y-axis or the equation x equals 0. All absolute value functions have a line of symmetry. So that's our parent function. Now, all these transformations or shifting, if you want to call them, happen when we're thinking about what happens to our parent function. In other words, if this parent function moves, the vertex moves down to there, there's some transformations going on. So we always compare or go back to the parent function like our transformations compared to the parent function. Now, there's some um, general rules we can use for transformations. Remember, we're going to be applying these to the different functions throughout the course, right? So here's some general rules. Inside the math symbol, okay, our math symbol happens to be our absolute value, right? For this particular function. That's our math symbol. We're going to use shift the graph left or right. Now that shift, either left or right, you're going to be looking at the sign. And going left or right, inside the math symbol, you actually go the opposite direction of the sign. So go opposite direction. Of the sign. Because my immediate thought here is I see a -2 in there. Figured, hey, I'll move it to the left too. But it's inside our math symbol, in this case, absolute values. You go the opposite direction. So our vertex from the parent function, we're going to shift it. Our transformation is our transformation is that we're going to shift our graph to the right 2 because that's opposite the minus. So I'm going to shift my vertex to the right 2. And all these other points stay the same. My slope was 1 over 1. And there's my transformation for this particular function. Now, I know that seems like a lot, but if you use your calculator, your handy dandy calculator, so we've already got our absolute value of x in there, right? All we have to do is add a -2. So that's these calculators are nice. You can do that. So I'm going to put a -2 in there, close a parenthesis, and hit my graph. And it did shift it indeed to the right too. And you can always get your points by hitting second graph, for your T chart. I can find my vertex by looking at my Y values when they start to repeat. So there's 1, 1, 2, 2. So I know my vertex is at 2, 0. So if I were to make a T chart for this, my vertex would be 2, 0, and then 1, 1, and 3, 1. Always go from your vertex, one less and one more. I know this is a lot of stuff and it's confusing, and it's just going to take some practice. That's why we do start with the absolute value function, because it's one of the easier functions to do the transformations and to see them. You really, like I said, you have to get these transformations down because we have at least a half dozen functions we're going to do throughout the course, and each one's going to get a little harder. Okay? So let's do number 2. What's going to be my transformation here? Yeah, left 3. It's inside our mathematical symbol, opposite the sign, and therefore it's going to be a left 3. You can just put down for your transformation left 3. We can abbreviate left 3. So if I take my vertex and go to the left 3, nothing changed as far as my wider, thinner, so it's still going to be 1, 1, and 1, -1 because of my line of symmetry. There's my function. And if you wanted to do it in your calculator right off the bat, you would just go to your y equals and change it to +3. Graph it. And there's my transformation, left 3. Okay. So that's the left-right shift or transformation. The next shift is going to be up or down. Notice that the 2 this time, it's a plus 2, is outside my math symbol. So outside the math symbol, and you'll know what I mean by math symbol, whether it's an exponent or parentheses or whatever for the different functions. Outside the math symbol, you're going to shift the graph, the function, up or down. And this time, you're going to follow the sign. So my transformation here in this one, it's outside the math symbol because here's my absolute value symbols, right? The 2 is outside, so my transformation is going to be up 2 because I follow the sign. Positive means to go up. Negative would mean to go down. And again, if you want to put it in your calculator and get your points here, but these are easy enough to do where we could do it right from the parent graph, right? Vertex was 0, 0 on my parent graph. So I'm going to just take my vertex and go up 2. Now, tomorrow, no, not tomorrow, after the quiz next week, we're going to do some problems where there's a whole bunch of transformations on it. That way, you'll want to use your calculator. Okay. So I'm going to take my vertex, go up 2, and again, my slope was 1 over 1, and line of symmetry means I have up 1 to the left 1. And there's my transformation. And again, if you wanted to use your calculator, just go to this time the absolute value was x. So I'm just going to delete this, delete that. And I get a plus 2 outside it. Now if I graph it, it's going to move it up 2. To get some points, hit that second graph. And there's my key chart of points. All right, number 4. What's my transformation? Down 4. Good. And again, easy enough to do this because there's only one transformation from the parent graph. I'm going to move my vertex down 4. My slope is 1 over 1 or 1 to the negative 1. And there's my graph. Was that a sneeze or a cough? Well, bless you. You're welcome. All right. These get a little more complicated. These last 2 transformations. So we're going to have 4 transformations total. The negative sign outside the math symbol. Okay. So if I have a negative sign outside the math symbol. The transformation is reflect. It's a reflection. Let's just call it a reflection. Now, in this problem, because our vertex is 0, 0, our x equals 0, right? The line of symmetry. So our x value is 0. we're going to reflect, our transformation is reflect, and you're going to have to write down reflect, about the x axis. Okay? Because wherever our vertex is, that's the horizontal line that we reflect about. In this case, our x equals 0. In this case, remember our vertex was at y equal 2. So if we had a minus sign in front of there, we would reflect about the line y equal 2. I'm sorry? Nope. If we had a minus sign there, you would just reflect about that y equal 2 line. Okay. Here we're going to reflect about the y equals 0 line because our vertex is at x equals 0. So we're going to have to reflect about the x-axis. Yeah, these get complicated. This is where you're really going to want to use your calculators. Okay. So I'm going to insert, and you can with these calculators. I don't know about the TI-84s, Aiden. With these calculators, I think you can. You're going to hit the second button. I'm going to insert a negative sign. Okay. So negative absolute value of x. I'm going to get rid of this plus 2. And I'm going to graph that.
You press what button? Okay.
Okay. Let's clear this. Let's start from scratch. Okay. I'm going to hit my negative sign, not the minus sign, the negative sign. Be careful.
Then
Then
do the
do the math button,
F button,
num,
then
bs,
yes, and then
x,
and then
close, graph.
Yep.
Okay.
Yep, I got it.
All right. And you're always going to want to do that because it's really hard. Like, let's put this one in with the minus sign. Okay. So I'm going to clear this. My example that I did here, I'm going to put my minus absolute value of x, close it off, and put a plus 2. And notice that it reflects about that y equal 2 line. See the difference? Now, this is also kind of a little bit of a pain because this one changes. There is a function we do where it changes. Might be 2 of them. But generally, if I have a number, greater than 1, I'm going to, this is actually my slope, okay, the number in front of the math symbol. If I know a number greater than 1, I'm going to stretch, or in other words, make it thinner, and I'll show you what I mean. I'm going to stretch the graph. Okay. If I have a number and I'll call it n, okay? If I have a number n that's between 0 and 1, that's how we symbolize a fraction between 0 and 1. Now this means like 2/3, 3/4, not like 5/3 because the fraction 5/3 is actually greater than 1. So it has to be a fraction between 0 and 1. We're going to compress or make it wider. the graph. Okay. So I'm looking at my slope. This is actually A. Okay. We'll get to this next week. It's a number greater than 1. It's going to stretch my graph. Now, like I said, I highly suggest using your calculators for this. So I have 3 times the absolute value. So I'm going to hit my math num absolute value of x, close it off, and graph it. So my vertex should be the same as the parent function. It's 0, 0. What's changing is the slope. So I'm going to go back to my chart. I'm going to look for that vertex 0, 0. Let's see, 0, 0, there it is. And my numbers, my coordinates for the ordered pair is -1, 3. So -1, 3. And then +1, 3. Do you see how it stretched it, made it thinner? Because this number was greater than 1. This is the hardest transformation of them all. So when you go to write your transformation, you're going to have to put stretch by 3.
So that's
Unfortunately, you could get away with it with the stretch, but not the reflect. The reflect you have to write out because we have a right here.
so like reflect number.
Yeah, you're going to have to write out reflect. You're going to have to. Stretch, I can get away with. You can get away with the S3.
If they were compressed.
Compress, you could do. Yeah, if that was a 1/3, you could say C 1/3.
Okay.
Got it? You guys are going to have to get this whole thing down because, and they do, like I said, they do get harder. The back gets a little bit more harder, but we'll do that after the quiz next week. Okay. You're going to have to kind of get this down because we're going to, like I said, we're going to apply this to at least 6 more functions throughout the course. Questions?